All right. So, in the instructions for today, I can find them. Are right here. Not again. There we go. Let me do this a little differently. There we go. Okay. So it says right here, for number 2 under team discussion, have each member of the group present a problem or type of problem that he or she is struggling with. As a group, discuss the problem or type of problem to teach one another. I guess I could start. Oh yeah, this kind of problem right here. When we're doing the completing the square. Kind of problem for me personally was giving me trouble. I don't know why, but it was.
You said completing the square?
Yeah, but when there's a number right here, I don't know why that's giving me trouble. It's not making sense to me.
Okay.
Are you screen sharing right now, Chris?
Yeah.
Oh, I can't see it. All I see is a green circle that like your camera's not working.
Let me see if I can adjust that.
I can see it.
Yeah, I can see it fine as well.
So can I.
Maybe it's just my internet. I don't know.
So the problem that he has written down is negative 3x squared plus 2x minus 2.
Gotcha.
So like I get that to start the problem, I have to divide everything by -3 to get rid of that, to make sure there's a 1 in that position. So that would be equals x squared. I guess that'd be minus at this point. Minus 3 halves x.
Wouldn't it be 2/3 x?
Yeah, you're right. Minus 2/3. Actually, negative divided by negative is a positive, so that'll be plus 2/3.
Mm-hmm.
Then put the -3 out front. X something squared something. Okay. So, so I know that number right there is supposed to be half of negative 2/3, which would be negative 2/6. Not mistaken. Squared and then you have to square it right here, right about there. So it would be y equals x squared minus 2/3 x plus, would that be 4/36? I totally crazy? And minus 44 over 36 plus 2/3. Does that sound about right? Or am I just totally crazy?
I guess all the problems that I've seen with completing the square, the last two numbers that they have in that form that you're on, or the step that you're on right now, are the plus 4 over 36 and minus 46. I don't really remember what happens to the plus 2 over 3, because that's how you're going to get that x minus. Yeah, it's going to be x minus 2/6 squared, and then it's going to be minus 4 over 36, and that would be the answer.
Oh.
At least that's how I understood it. Maybe I'm doing it wrong too.
Maybe. Because I remember someone saying that you have to add this to both sides to make it even, you know?
Yes.
So
Pull that out of the parentheses. I believe you add the -1 out. Hang on, let me go grab my notes. I'll be right back. In the homework, we had one of these, and it took me like an hour to finally figure out how to do it.
no kidding, same.
It takes me like hours, no matter what problem it is. You're like, what is?
Oh. And then I want to find out which one it was that I had to go through. And I always have to do like the example problem.
Dude, I did every question.
Yeah, multiple times, and then I finally figure out how to do the actual problem. Okay, let's see here.
That kind of shot myself in the foot with the quiz last week. I didn't procrastinate. It just took me way longer than I thought, and I didn't even have enough time to really understand what I was doing.
Yep, I'm right there with you. Okay, so let's see here. Where are we? Okay, so what it should be after the. So I can kind of walk us through it, like with my work, and see what you guys think. I'm not sure. This is the part that I struggled with on this problem. How do you get the 3 out of, like, outside of the parentheses? The part that I always struggle with. So I just do it.
Yeah.
Let's see. So you would have the x inside the parentheses. You should have, in like the beginning, it should be x squared. X squared minus 2/3, and then it goes to plus 4 over 36 minus 4 over 36, and then close parentheses, and then it would be minus 2. Yeah, you can leave it the way it is there in those parentheses there, and then it would be 2.
Plus 2?
A minus 2.
Minus 2.
The minus 2 up top.
Yeah, so I think
Oh, yeah.
the reason why it's the minus 2 is because, like, I kind of have the steps written down here. This is like from the first problem, the first homework ever. You have to bring c to the other side, and then you add half b squared to both sides.
Yeah. There's an MX. Yeah.
Okay.
Let me grab a pen and I can kind of work through it here. Hang on.
Wait, so wouldn't you use the quadratic difference equation to solve that question that you're on?
Hmm.
Let's see. Oh, gotcha. Okay.
Hmm.
Oh yeah, yeah. Okay.
So the answer that I got has a involved. Does that sound right?
Can you repeat
Has
that?
a what?
The answer that I got has a square root involved, like in the answer.
Hmm.
Because that's how it was like in the beginning when we were doing completing the squares, like back in chapter 1.
Could be.
So the answer
Sounds
that
like
I
it
got
could be
is,
right.
for that one would be 2/3 plus or minus square root of 4/36 minus 2/3 equal to x.
Hmm. I just pulled this answer from my math lab. Actually, that's where I got that answer from. So I don't know if that would be right or
Well,
wrong.
let's FOIL it out and see if it works.
Let's do that right now. So I guess it would be x squared minus what would that be? I'm going to do things a little bit less complicated for me. X.
That's how we did it, okay? To get 236.
Square. I guess.
Is that what a third times a third is? Is 2/3?
I think. Am I totally crazy?
I thought it was 2/9. So you multiply the top and the bottom,
Yeah.
right?
Right.
Then you just
Is it?
Yeah, it's 1/9.
1/9?
Oh yeah, 1/9.
Just multiply the numerator and the denominators.
Not bad.
Wait a minute. I thought it was like this. Just a second. And then you multiply it by 2/1. And that would be 2/3. I thought it was like that, but maybe not. Where you multiply this by this.
Yeah, so it's top times. You just go across with multiplying.
So 1 times 2 would be 2, 3 times 1 would be 3. So it would be 2/3.
Yeah.
That's what I thought.
Yeah.
There we go.
Wait, why did you replace
So
one-third?
you're multiplying 1/3 by 1/3 though.
Yeah.
Oh, 1/3
So
by
it's
1/3.
1/9.
Oh, sorry about that. I thought
You're
I was
good.
doing 2/3. That's where I'm. Okay.
Yeah.
Okay, we're good. And then that would be x squared minus 2. Well, that'd be 1/9 too. 1/9.
No, because you're adding them.
Right. 2/3.
In,
That
in this case, you're subtracting them, but yeah.
would just be minus 1/9.
Plus 1/9.
Oh, plus 1/9?
Well, yeah, and it's negative 1/3 minus 1/3, which is negative 2/3.
Oh, I'm totally out of it.
And then don't forget your -3 on the front, which will change your 2/3 to a 2.
And then minus 1/9, right?
Yep.
1/9. Okay.
And then you close parentheses and subtract 5/3 from that. To the answer at least.
How are they getting that then? 2/3 minus
So
1/9?
you distribute your -3 across.
Oh.
How did you get the 5/3 again?
Yeah,
The 5/3 was part of the answer. So we're working the answer backwards,
Oh.
trying to figure out how we got the answer.
Yeah, this one in yellow comes from the My Math Labs, so we're trying to figure out why.
Yeah.
Okay. -2 times -3 is a positive 6. 6/3. Oh, it would be -3 x squared. That's
I understand why.
-6/3
Equals -2.
Right.
Yep. Okay. Yep. Makes sense.
Oh, yeah. Okay. The question is, how did we get from here to there?
So I did number 1, the one we were working on at the beginning,
Mm-hmm.
all the way through following my notes, and I got the answer 3 parentheses x squared minus 2/3 x minus, or close parentheses, minus 17/9. Because what you have to do is when you pull the -4/36 out of the parentheses, you have to multiply it by -3 before you can pull it out.
Let me see. Because someone told me that you always divide this number by 2, put it down there, square it, and put it back up here.
I mean, yeah, that's how you get the perfect. That's how you're able to.
You get the perfect square, yeah.
Yeah.
But then you have to add that to both sides. This makes sense. Okay, this could be simplified down.
And then when you're on the outside, because you have +4/36 or -2 minus 4/36, then you have to take the 2 and get the same common denominator. So then you can combine the 2. Then it'd be
72/36.
Yeah, 72/36. And the difference between those would be
-5/3. -72 minus 4.
Because then I took it down, and because it comes out to -68/36.
-68. Okay, yeah, that makes sense.
And then you can reduce that down by the factor of 4, which gets you 17/9. But then you can't take 17 down any farther. At least I.
Well, why did you subtract -4 from -72? Wouldn't you be adding it?
Oh, that's probably true, huh?
It'd be like 76/36.
It is a negative, huh?
Maybe this then.
76/36. Yeah, and then what would go into both of those?
5 doesn't go into 76.
No.
No.
So why are you subtracting the 4/36? That's what I don't get. Where'd you get the 4/36 from?
Oh, so you have 2/3 x right here. You have to divide that by 2 to get 1/3 and square it to get this.
1/3 times 1/3. 1/3 times 1/3 is 1/9.
Maybe.
4 would go into it.
Yeah, it'd be 19/.
Yeah, so it'd be 19/9.
Negative.
But then again, I don't know how they're getting 5 negative. Yeah, I don't know how they're getting 5/3.
I don't know.
Well, let's just, okay, so 3 times,
Because 19 is a prime.
well, 3 times, is it 12 gets 36? So
Yeah.
negative 5 times 12 would
That's
be
negative 70. No.
negative
Negative 60.
So somewhere we're getting negative 76 instead of 60.
I gotta go to the bathroom real quick, so I will be right back.
All right.
All right, we'll keep trying.
Yeah.
So can you re-walk me through what y'all are doing with the 4/36 whole deal?
Okay, so you have to take the 2/3, the negative 2/3 x,
Mm-hmm.
and you have to basically multiply that by like half of itself, and then you square that. So we got 4/36 because 2 times, yeah, 2/3, and half of that is 2/6, and so then you square the 2/6, and you get 4/36.
Well, 2/6 is 1/3. If you square 1/3, it equals 1/9.
Oh, that's true. So I think that's where we're messed up.
Yeah.
That's true. So then what would be?
So are you working the problem from the answer that you have from Chris? Or are you working it the way that we're trying to?
Let's see here. Do you know where he got that extension problem, or that problem number 1?
I don't know, honestly. It's not an extension problem.
Yeah, I was looking.
I think it might be on the homework, though.
Probably was. I just know you have to take, so starting with the negative 3x squared plus 2x minus 2, you have to take that and pull the 3 out, so you've got to divide every.
Right, so it makes it positive 2x, or 2/3 x, and then negative 2/3. And then you FOIL that, and it makes x minus 1/3 squared. And then you have to take into account that you're multiplying that by negative 3, which gives you, what is it, negative 3/9? No. Gives you negative 1/3. And then you, with the answer that Chris has, you subtract 5/3 from that, which gives you negative 6/3, which gives you negative 2. So the 4/36 doesn't make sense to me if we're just squaring the 1/3.
It's, yeah, take the.
Wait a minute. Wouldn't that be 1/9 then?
Yeah, it's
Yeah.
negative 3x plus 2x, and then plus whatever negative 3 times 1/9 is.
Wait a minute. Where are you?
So if you FOIL it out, like we've trying to been doing, it would be, what you would get is, x minus 1/3 times x minus 1/3, and get x squared minus 2/3 plus 1/9, and then you have to multiply all of that by negative 3, so you get negative 3x plus 2x, and then whatever negative 3 plus 1/9 is. And then
it's negative 1/3.
Negative 1/3?
Yep.
Okay, so you have negative 3x squared plus 2x minus 1/3. And then you still have that minus 5/3, which is what they have. And then, negative 1/3 minus 5/3 is negative 2. So that's the answer.
Yep.
So where did I mess up is, I guess, my question.
Start factoring it. So it would be, typing it out would be easier to
Yeah.
Right. So we factored it out, and we got the original problem. We're trying to help Chris. We're trying to help you with factoring it out or solving from
this
the
top line.
problem. All right. So the top line, you divide everything by 3, and you take the 3 and put it in outside on a parentheses.
Yeah, right there.
All right. And so you have x minus 1/3 squared.
Mm-hmm.
The negative 72 over 36 doesn't make any sense.
No.
So, because you have x squared minus 2/3 over 2/3 x plus 2/3. And so you're going to take that and factor that into what you have at the bottom with that. Right.
Yes.
So erase that third line. So all you need is the first and second. There you go. All right. So that's what that comes down to. So you got x minus 1/3 squared. But in order to have an answer to that problem, you have to take into account that you're multiplying everything by negative 1/3.
Mm-hmm.
And then you have to subtract the 5/3 at the end to make it add up to negative 2 at the end, if that makes sense. You're basically pulling that number in to make the answer equal the original problem. So you kind of have to make that up.
Okay.
Make it solve it. But once you get there, you just tack that onto the end, and that's the end.
Okay.
I still think there's some easier way to get that 5/3 that we're not realizing besides just kind of figuring it out, winging it.
Yeah. I mean, you have a negative 2/3 right there, a positive 2/3, and a negative 1/3 right there. That's probably just a correlation. Those all happen to add up to. No, they wouldn't add up to that.
So 1/3 times 1/3 equals 1/9.
Yeah.
So in order to get the I understand. So you subtract what is it? You subtract 1/9 from 2/3, and that's how you get. No, that doesn't make sense. All right.
Let me see that something.
Are you able to so you got that answer off of My Math Lab?
Yeah.
Were you able to do the example, show me how to do this problem?
Yes.
Because like that would walk us through this entire process.
Not at this point now. That the score, it's weird. I don't know why it does that. Once you get a score, you can't go back and do anything. It just shows you the score.
Oh.
Wait, so which homework is this from? Or is it from homework?
Yes, from homework. It's let me see if I can't see. I think it's from week 3, lesson 1.
All right, let's see if I can find it.
And it's lesson 3. Just kidding. Lesson 3.
3. Okay.
And it's so problem 19 looks like 3-1 3.1.119. 3.1.19. Or question 4 of 12. It seems like. Question 4 of 12. Go with that.
All right. You said week 3 or lesson 3?
Week 3 and lesson 3.
All right.
Problem number 4.
Problem number 4. All right. Let's see.
Like the only way that I can see that it would mildly make sense is if you put 2 into a fraction already of so instead of the original problem being negative 3x squared plus 2x minus 2 is if you made it negative 3x squared plus 2x minus 6/3.
Oh.
You could just take out the 1/3.
Okay.
Don't even have to really divide anything by 3.
I see what happened. What they're doing, at least. So you take the equation and you put it into the form of a times, you got a as your first value, and then you do x minus h squared, and then you add k onto the end. So you got negative 3x
Oh, right.
plus 2/3 squared, or 2/3 x squared, and then minus 2. That makes more sense than what I was saying.
Hmm.
And you subtract 2 on the end.
Yeah. How do you get from this to there?
Yeah, I have some beef with this problem.
So you're going to take 1/2 of the linear term, which is the 1/3 in our case, and you square it. I think, hold up 1 second. A times x minus k. K equals, k is 2/3 in our case. So if you take,
Can you guys hear me?
yeah.
Okay, sorry, my mic was not working for the longest time. I've been trying to figure this out as well. I'll try and screen share it, but this is what they did. This problem here. And so they've got the original equation here. Then they multiplied everything, or they added and subtracted 1/3. Then they factored. And so each one of that's the original problem there. Then they factored it all throughout. Then they essentially just completed the square here. So and there's the original again, and that's the answer. But
Would it make sense? I feel like it would be a lot easier if in the beginning of the problem you just took c out and you subtracted 2 from both sides, or you added 2 to both sides, and then you complete the square using negative 3x squared plus 2x, and then at the very end you subtract 2 again from 1/3.
That would give you negative 5/3. If you subtracted 2 from negative 1/3.
Yeah, so if you just take c out in the beginning, that negative 2 out, and add 2 to both sides.
That makes sense.
Oh. Maybe.
So I have a question. How long are these Google Hangouts supposed to be?
Oh my gosh, you're right. If you take this number,
It's supposed to be about an hour.
All right.
if you take this number and add it to this number, bam, you get that number. That's what it is. Okay. So I think since we all didn't really know how to do that problem, I think that could count for, unless you want to do each one to go through and.
I do have one that if you guys don't mind helping me out with. I don't think it's
Sure.
that difficult. So it's actually on the written quiz that we just had to do for our individual quiz. Let me try to find it.
Was it the last one where it had the fraction and you had to
It's like the f parentheses f minus 1. So it's like
Oh, so it's
parentheses
f of
1
f of the inverse.
Yeah. So what is? I tried for the longest to figure that out, and I was like, I know it's not that difficult. I just need a little bit more explanation.
I think we might, yeah, like this, number 4.
Yeah.
Because I think we're going to do that today, actually.
Yeah, it's like I don't know if it was just the wording that she had it at. I couldn't understand it because I know I've done one. It's just I couldn't figure it out.
So what was the problem?
It says use this same equation for both of them. It's 2x plus 5 all over x minus 2. It's like f of x inverse.
Oh, yeah.
So I think you're supposed to multiply the two together, but I'm not 100%.
F of x, F of x, and there's a little like -1 right here.
Yeah. And then before that, there's also, like all that would be in parentheses. I don't even know. Do you guys know which one I'm talking about?
Yeah, I know which one you're talking about. So you have to take the inverse of the original problem where you switch the x's and the y's.
Yeah, so it changes those to y's.
Do you mind if I screen share? Because I have my quiz. I typed it up and I can share it.
Go ahead.
All right.
I figured everything else out.
So
yeah, because I had a question on I think it was the last one of the quiz. So if you screen share the quiz and I can just see how you.
So can you guys see that?
Yeah.
I don't know what you can see and what you can't. So, all right. So there we go. So that there. Down. All right. So I'm gonna look at this. This is what I got for. Can you see it, or do you need me to zoom it in?
I can see it.
I can see it.
All right. So, and just a heads up, I'm not sure what my grade was on the quiz, but I'm pretty sure it's right because, I mean, I don't know, but. Alright, we're gonna minimize that so it doesn't freak you out. Alright. So what I have is x equals 2y plus 5 over y minus 2. That's the original problem with x's and y's traded places. And then to solve that, you just take the x's and put them back. And replace the y on the other side, if that makes sense.
Yeah.
Does that all make sense so far? And then with number 2, you take the outside of the problem, or you take the inverse, and you replace x with the inverse. And put it in parentheses and put everything else on the outside. You distribute factors and divide. And you should come up with x plus 7 over 2 equals f of f to the negative 1 of x. Or at least that's what I got. So.
Gotcha.
Mm-hmm.
Should be x plus 6, so I divided wrong. Oops. Looking back at it. Oh well. It's okay.
And how do you do number 3?
Number 3 is, it's really weird. But
Right.
you replace x plus h in for x. So that would be x plus h squared minus 2 parentheses x plus h plus 5, and then you do minus x squared minus 2x plus 5 all over h. And then you FOIL everything out. This will be x squared plus h squared plus 2x plus 2h plus 2xh. And then you've got 2x plus, yeah, you've got 2x plus 2h on the other side. And then plus 5. And all of the x squared minus 2x plus 5 cancels out. So you're left with 2xh plus h squared minus 2h over h. And you can make it h, or 2x plus h minus 2. Because you take off 1h from either of the components to the problem. Does that make sense?
Yeah.
All right. So the reason I color coded the second part was to show that those canceled out, to leave you with the rest of what it is. I should probably change that highlight color. That's a really dark highlight.
All right. What else do we have to do for today?
So if you go to my one screen sharing,
Yeah.
so we just have to do 1, 2, 3, 4 discussion problems, and that's it.
Okay. Let's
So-
look on this.
So I actually have a dentist appointment coming up soon, so I might have to leave halfway through.
Okay, I'll give you the 10 points
All right, cool.
because that's not fair to you. So
Yeah, just a heads up. It just came up. Got back from the mission and had to go to the dentist. Fun stuff.
where'd you serve your mission?
Utah.
Nice.
Ogden.
I'm gonna jump
Nice.
to the bathroom break before we do this.
Alright.
Okay, let me get a graph of that.
It's too bad a lot of these are graphing, because if we want, we'd be able to do them a lot faster. It's just trying to make the graphs.
No kidding. Kind of a rough sketch anyway.
Not bad.
Okay.
It's good for having to makeshift it on Word.
Original, right?
Yeah, it's basic. Because there's a absolute value right here, so that's basic absolute value. So that tells you that that right there is absolute value. And the domain, well, actually, we should probably do the transformations.
Yeah.
I have to list those.
So this one's flipped. Then is that shrunk or width? I can't remember.
I believe.
Not width. That widened. Stretched, widened. I don't know the words.
Ah. Okay, first off, we flip it. And I believe that is width. Yeah, so it's a more acute angle by 1/2.
Yep.
Yeah.
So, not that. Don't want to do that. But we know what it's supposed to mean.
Yeah, you can just write it down. Just
Yeah.
Let
Shrunk by.
narrowed, maybe.
Yeah.
Narrowed by. Yeah.
Narrowed by. And then inside it, there's a -4.
Wouldn't
So-
that be right 4?
Yeah,
That's
it's about right
opposite.
4. Yeah,
And then
Then up to 3.
right 4 and up 3.
yeah.
Yep, that's what it's supposed to be. Okay.
And domain, that one's just a negative infinity to infinity.
Whoops.
Yeah.
Negative. And then the range.
It's negative infinity to 3.
Yes. Oops, this is a square bracket. Negative
Alright,
infinity.
you-
No, yeah.
You've got the square bracket on the other
Yeah.
side, though.
You're right.
And can you explain why the negative infinity has a square bracket? Sorry, that's
No.
one thing I've mentioned.
That was my mistake. It's a -3 that's supposed to have the square bracket. But the -3 has a square bracket because we
It's
include
a
negative.
positive 3, isn't it?
Yeah, +3. You're right. It's +3.
Alright.
Yeah. Because we include +3. It's like
Yeah.
a definite.
But
So it's a square bracket if you include the number, and it's parentheses if you don't.
Yeah.
Right.
So sometimes there'll be like with piecewise functions, there'll be like a gap between some of these. So that one you wouldn't put a square bracket.
Gotcha.
and then you'd have to put a union, but that's
Yeah.
and the symmetry.
Okay.
I don't think it has any.
think it
The symmetry is like
Right there. That line.
well,
Isn't that x equals 3? Or y equals 3?
x equals 4.
X equals 4. I think it is x equals 4, the line of
Yeah.
symmetry.
Is that what it's asking for, or is it asking for the odd even thing, where it's like either about the origin or around it or whatever? This symmetry thing is weird.
When I've done it on my math labs, it'll ask me just for like an x equals or x equals exactly. And it's accepted that as the right answer. So I think that's what it is.
All right, whatever works.
Because that would denote this line right here. So
Yeah, I got you.
And we already did this.
Function.
Absolute value function.
Yep. Intervals increasing and decreasing.
Oh, this one I don't like at all.
It's just infinite.
Increasing is easy because that's just your negative infinity up to your set point, which would be 4.
Yep.
Right. Negative. Oops. Negative infinity to 4.
Yeah, because you read the graph left to right.
Yeah.
And decreasing is just 4 to infinity.
Oh, yeah. Maybe that was a lot easier than I thought.
Yep. Make sure you put the inclusion bracket on the 4 though.
Yes. Oops. And we have 4 to infinity.
Yep.
There we go. Done.
Yeah.
Okay. So here's some of that difference quotient business. And you want to replace that x plus h with anytime you see x.
Yep.
So 3 x plus h.
I'm gonna work this one out too because
Squared and minus 2 times x plus h. And then plus 1 minus the actual function itself. So 3x squared minus 2x plus 1. And divide that all by h. So we need to do a little expanding here. Let's see. All right.
So for that, I got 3x squared plus 6xh plus 3h squared. Can't see if that's plus 2 or minus 2, but then 2x
It's
plus
a minus
2h.
2.
Okay, yeah, so then it'd be negative 2x minus 2h.
X plus 3x squared.
H squared.
Oh, 3/8, thanks.
Yeah, h.
8 plus 1.
Well, you gotta put out the minus 2x minus 2h as well, and then plus 1.
Right. Minus 2x minus 2h. 2h plus 1.
Yeah.
Is that a plus? Is that a plus? That's a plus. Yeah, that's okay. Yeah, and then minus 3x. There we go. Okay, so let's do a little color swapping. That one and that one.
Yep.
That one are gone.
And that one gone.
That one and that one right there, which we'll do for green. That one are gone. And this one is gone as well. Oops.
Mm-hmm.
No, the one's not gone, is it?
Yeah, it is. 1
'Cause
minus.
it's
That is
one minus the plus.
Yeah, sorry, my bad.
You're good.
Is there
I
anything
just forget to
else?
factor the negative here.
And then Take it down another line. 6hx plus 3h squared divided by h, and we can factor out an
Or
h
plus 2h.
plus 2h. I think I knew I was forgetting something.
You're welcome.
Not that. 2h. Okay, there we go. And then we can factor an h out of the whole of this thing.
Mm-hmm.
Comes.
And that should leave you with 6x plus 3h minus 2.
And so, yeah,
That's
that,
your
and
answer.
that can cancel. That should be the answer. Yay. Final answer. Woohoo. Okay. And then now we're going to do a little inverse one. And after that, the piecewise, and we're done. So let's do y equals 2x plus 1 in parentheses divided by parentheses 3x minus 4. And we're going to swap the y for an x and the x's for y's. We're going to solve. And we're going to take this 3y minus 4 and put it on the other side. Like that. And remove the brackets. I will make that 3xy minus 4x equals 2y minus plus 1. And get that one on the other side. That's a minus. Actually, that's not right. Minus 1. How do you get rid of this y right here?
You take the 2y that you have, and you subtract it to the side of the 3xy, so you can factor out the y, and take the 3x minus 2 and divide
Oh, wait, so you take
4x
this,
plus 1.
this 2y.
Yeah, where you feel like you're supposed
So-
to subtract the 1 on each side, you're actually supposed to switch the y and the 4x.
Yeah. So you take the 4x and you add it to the other side, and you take the 2y and you subtract it from the other side.
This one gets the plus 4x. And
Yeah.
this one gets a minus 2y. Is that what you're saying?
Yeah.
Yep. Then you factor out the y, so you have a single y, and then you have
Oh.
3x minus 2 and 4x plus 1.
That's clever. 3x minus 2 equals 1 plus 4x.
And then you divide by the 3x minus 2.
Equals parentheses 1 plus 4x, close parentheses, divided by 3x minus 2. That's simple enough to me.
Yep.
Now we're going to graph these piecewise functions and identify the domain and range of the piecewise function. Forgot to put that. Domain, range. Okay. And looks like we have a line right here, 2 lines in fact, and a parabola in the middle.
Mm-hmm.
So I'll add those basic shapes. Oops. Looks like we have a positive line and then a negative line down here.
Yeah.
We want to take that and flip it. And then we'll insert that parabola and then we can start. Okay. That should work. There you go. Okay. So for this first one, we have for everything x is
Less than
negative 2. It should be 8 plus 2x.
So that's 2 over 1 is your slope.
2 over 1 is the slope, right? Yeah.
Right. So your domain is negative infinity to a negative 2 with just parentheses.
Don't give me that. Okay, do that. Oh yeah, okay. Let me just adjust it a little bit. See domain and range individually. Range and domain and range. But actually, I'll move that over. Okay. You said the domain for that one was negative 2 because you have to subtract it. No.
Negative infinity to negative 2.
Right. You're right.
Yeah.
Hey, I've got to take off. I've got to head up to school. So,
All right.
got my next class.
All right. That sounds good to me. Okay.
Okay, thanks, guys.
I've got to take off. I have a dentist appointment, so
Sounds good to me too. I guess we'll.
we'll see ya.
Okay, we'll see ya.
All right. Bye.
See you later.
All right. Yeah, I gotta go eat some breakfast real quick. I'm just kidding.
Okay.
With the piecewise function, we're only going to have one range because once you put all the graphs together, it should merge into kind of one graph type thing. So we should only have one range for piecewise functions.
So I'll get rid of those. You're right. We'll have that one domain. We'll have the one central range up here. Okay. And then that looks really confusing. Let me adjust that. That's better. Okay, for the parabola, I think
The second one, is that negative 2x or is that regular 2x?
that's a negative 2x. Sorry, I didn't move that.
Oh.
So it's a parabola, so that tells you that it should be negative infinity to infinity. Nope, that's not right. It should be negative 2 to 2. Correct?
Well, let's graph this piecewise function. That way we can kind of see what's going on with it.
Good idea.
Graph all three pieces, and then we can just see what because you'll only have one domain and range for the whole thing. So once we're able to see, where the graph's lining up, we'll be able to figure out the domain and range a lot simpler.
Yes. And this starts at negative 2. But that's just basics. So.
And that should be, yeah, there we go. I was going to say it should be.
A lot steeper. Yeah, there's that.
And then
shrink it down.
So x ends at negative 2.
Yeah. Ends at negative 2, you said. Yeah, like that.
Well, no, x is less than negative 2, so it would have to be the other way. So, like, where you had it, yeah.
That's right, okay.
Yeah.
And this is a positive parabola, so it goes the other way. And this between 2 and negative 2. So, That's not the right button. Something like that. Oh, but it's just a basic one, no shifting. So right about there, like that. And then looks like this one might. What the? Weird. Okay, so this is x is greater than or equal to -2, but it's the opposite, so like that. About like that?
Yeah, and then do we need to have closed circles and open circles?
Yes. So it looks like this one has a closed circle because it includes the point. So let me see if I can add that.
And they should also be touching, right? Because the piecewise function should form one graph. Because it's technically one function.
Well, it doesn't have to necessarily touch. They just have to match up to
Align.
Yeah, to somewhere on the x-axis.
Oh, okay.
And that's an open circle because it's a greater than or not equal to, I should say.
Is there a way to do it? Oh, look at that.
That should be what it is. And then same with that first one.
Is there any way that you can make the parabola more even? So it should look like just like two lines like that with like a little smiley face above it.
What do you mean?
So like on mine, I'm just doing it drawn out, but it should look like that.
Oh, right. Because it should be on the origin.
Yeah.
And
the little parabola should be equal because it stops at -2 on both sides, or on two -2.
Right. Trying to see if I can. Nope, not that. Not that. Not that.
If you can't, it's fine. Whoever's watching this will know that we tried because we talked about it.
Yeah. But that's the idea. It's supposed to go through the origin. And that's not supposed to be so flat at the bottom. Yeah, see? Yeah, that's there. I found it. We square, and that's as far as it goes that way. Anyway.
We get the idea.
Yeah, that's it right there. This is the gist of it.
So this one would have a domain of -2 to 2.
Yeah, in parentheses. There's no bracket.
Oh, yeah, because it doesn't include it. Yeah.
Yeah.
Just that there. And this last one would be closed parentheses on one side, 2 to infinity.
Yeah.
And that means this one has a closed parentheses as well, a regular parentheses. And it looks like the range for the whole thing. Oh, I can't tell. What would the range be for this whole graph?
Well, if you plug in, so I think it'd be 4 to negative infinity. Because you would just plug in 2 for x to find what y would be. Wouldn't you?
Because you can. Yeah, because it's going down this way. It's going down in a negative direction. But it only goes up to.
Yeah, we have to figure out what those points are on the parabola. And so if we have an x value, and we do, it's 2, shouldn't we be able to just plug in that 2 for x, and then 2 squared is 4, and that would give us our where it starts?
Yeah, that makes sense. Yeah.
Parentheses 4 to comma negative infinity.
The negative infinity come first, though?
No, because I think you're going from top to, well, yeah, I guess you're right. I don't know.
That's what they told. That's what I thought, anyway.
Yeah, because the lower number always comes first, I believe.
To 4, yeah. And it's rounded because these are both open. So I think that's good.
And then the domain is negative infinity to negative 2, negative 2 to 2, and then 2 to positive infinity.
Domain is, so we start with negative 2. You're right.
Negative infinity, yeah.
Negative option 5. Negative. Negative infinity to 2.
Negative 2.
Negative 2, right?
Yeah, negative 2.
And then, is it a little u or no?
I
don't think so.
I don't know. I don't think so. I think it's just a comma. I don't know what that u means. It's like all real numbers combined or something like that.
And then this one is, then we have negative 2, comma 2. Then we have
Close. You have bracket.
2 to infinity.
Yeah.
Which makes sense because this is what matches right here too.
Yeah.
I think we're good.
Sweet.
Do we check our answers with the thing?
Yeah, let me check them.
What are you checking on?
Oh, this for the Google Hangouts. Every time you, part of the instructions is that you go and check your work against
the
answers. Yes. So under instructions at the bottom, it says the key. So I'm going to shrink that back down. So we have that on one side, and we have our work right next to it. There we go. Can you all see that?
Yeah.
Yes.
So reflect, flip, same thing. Shrunk by 1/2, narrowed by 1/2. Shift right, up 3. Yep. Domain. Yep. Absolute value function.
Why is there range? Why does it have the negative infinity in a bracket?
I think they messed up because you can never.
You can never include negative infinity in something.
Yeah.
They include negative infinity.
Yeah.
Right.
So symmetry, right? X equals 4, increasing negative infinity to 4. They did not put a square bracket. Guess you don't put square brackets, but I thought you did. My math labs put a square bracket. So
I'm pretty sure you're supposed to put a square bracket, but
yeah. And then the
that graph does include 4, so
yeah. And then the graph looks very similar to ours, so I'm going to give that a pass. And we're right again on this one, same. And ooh. Oh yeah, same. They just put the 4x before.
Yeah, 4x and we're swapped, so that's the same thing.
Domain, all real numbers. Interesting. They put a square bracket.
No, theirs is not. The answer key doesn't look right because they don't have greater than and equal. They don't have equal tos on any of them except for the last one. So only the last one should have.
Yeah. Weird. And so according to them,
we got the range right though.
There should be something like that. I don't know.
which I
I
don't
don't know
know.
why they. I mean, maybe if we put it through and plotted some points, if we made.
Let me check with a little graphing calculator and see what it does.
The same thing. Oh, I was meaning to ask you guys, what is the class policy on graphing calculators?
I think it's fine. Just you can't use them on test or quiz.
Right.
My math teacher last semester didn't even allow us to use calculators at all, anytime, anywhere. It's ridiculous.
Not use calculators at all?
No, not during class, not on the homework. It was so ridiculous. Not that I followed that rule anyway.
That's pretty lame. I hate teachers that don't allow you to use the technology that is now available.
I know, that's like why. Anyway, it's kind of stupid, but.
So on a graphing calculator, how do you make it so you have the limits? Like, how do you make it so the graph stops?
I don't know, honestly.
I think it's, I don't know.
Either way, we can look at examine the graph to see if.
I mean, we got all the graphs right, but I don't know why they have it stopping at 4 instead of at -2.
Oh, so if you graph all the graphs together, the intersection of all three graphs is at -4 at y equals 4. That's why they have that. So the graphs do intersect like this. So if you were to continue the graphs on, the graphs wouldn't intersect both of them at -4. So that's probably why they have the intersection to be like that. So I guess that makes sense. That's where the...
Well, it makes sense if you just graph the functions, but then they also have the stipulations of x is greater than or equal to 2,
Yeah. I don't know. I don't know why they have it like this.
I guess it makes sense because you are stopping it at x -2. We had it too far.
Yeah. Yeah, that was the deal. But I think that makes sense now.
I still think we have it right.
Let's change our domain then to all real numbers, because if they're counting it as it continues all the way through, then
yeah.
I would
can basically continue on. So
I don't know though.
No, I would keep it how we had it, and then just like off to the side have like all real numbers ? Because the teacher has it. I don't know. And like a different shade.
All RAL numbers. I'll italize it, bold it, and then highlight it. Okay, there you go.
That looks good.
that'll work.
Anything else? Any other questions? Final thoughts?
Nope, I think I'm done with math for right now.
Yeah. All right.
Okay, I think we're good. I will see.
Homework, everybody.
Yeah, you too.
See you on Thursday.
Yep. Bye.